Hi everyone, this video is an intro to surface area. So before we get started with some calculations, we're going to go ahead and define what that even means. Surface area measures the total area on the surface of an object. So when we talk about surface area, we're talking about a 3D shape as opposed to regular area is just a flat shape. So it measures the total, keyword there, area on the surface of an object. Or you can say on the surface of a 3D shape. Okay, so if I'm looking at surface area, it's like if I were to wrap a present, how much wrapping paper would go around the shape, on the surface, on the outside, however you want to think about it. Now, in order to talk about surface area, we also want to talk about lateral surface area, which is basically the area of everything but the bases of the shape, which I'm going to define bases first, so then we can go back and define lateral surface area. So the base is what the shape sits on, or the bottom of the shape. Okay, or you can say what it sits on. And this has to be a 3D shape again. Now further, some shapes have multiple bases. So it's the two parallel sides, the two sides that are parallel, if you have like a prism, for example. So like this one, the bases would be the triangles, because those are the parallel sides. So bases, if there are two, then they're parallel. So if there are two bases, then they are parallel. Okay. Now, lateral surface area, again, is the surface area of just the lateral faces. A lateral surface area is the surface area, but just the lateral faces. So in order to understand what that means, we need to know what lateral faces means. So the last vocab word is lateral face. It's everything but the base. So the sides that are not the base. So if you remember that song, All About That Base, last year we remembered lateral surface area is all but the base, if that helps you remember it. Okay, so I'm going to tell you what these are in terms of a few pictures. So surface area, if I'm looking at something like this solid here, is just like how much area is on the outside of the shape. So if I take all of these different sides you see on this solid here, this rectangular prism, we want to know what the round is. Now, the lateral faces are everything but the base. So that would be this front side here, this side here, this side over here, and the back there. Okay, now the bases would be the two parallel sides that it sits on. So this is one base up here, and this is another base. Okay, if I wanted to find lateral surface area, I'd find the surface area of everything but these two bases that I shaded there. The reason you might do that is, let's say you're trying to put the roof on a house. Okay, if you take a look at a house, it's going to be some sort of rectangular prism with some sort of triangular pyramid on top. You might want lateral surface area because if you're putting roofing on, you just want this part here, and you don't want to put roofing on the base here. So that's an example of where you might want lateral surface area instead of full surface area. Okay, just to talk vocabulary a little bit further, these are the bases if you have a triangular prism. The rectangles here would be the lateral faces. So all three of these rectangles are the lateral faces, so even the one back there. Okay, so for each of these problems, you're going to draw the net and then find the lateral surface area. And I'm also going to include the total surface area. So lateral, and then we'll find total. So for this one, it's a rectangular prism. So if you look at two bases, they're rectangles, and then all four sides around here are also rectangles. So if I unfold just the lateral sides, you just have four rectangles kind of put together like this. So I'm going to draw the net, which is the flat shape. Okay, then the bases are attached to those lateral sides, and the bases might look something like this. So if you folded that up, you would have the net of a rectangular prism. Now, there's multiple ways to draw it. This is just how I'm drawing it. And I'm also going to label that. So the bases are what's down here. One side of the base is 4 inches. The other side of the base is right here, which is parallel to this 2 inches. And opposite sides are congruent in a rectangle, so the other side would be 2 inches. which would be right here. Okay, so this is a base of sides 4 and 2. So that means this one's also 4 and 2 since they're parallel bases. Now the lateral surfaces, some are a little bit different. So this front one you're looking at is a 3 by 4. Okay, so if this is 4, then this side is 3. And there's going to be another one of those that's behind it. So this has to be 4. And then if this is 3, then this is also 3. So there's another 4 by 3 shape that's on the back there. So this would be 3 also, and this would be 4. Okay, now the two side ones, let's take a look at what these might be. So if this is 2, then this is also 2 here. And if this is 3, then this is 3. So you're also going to have 2 of the 2 by 3 faces. So this is 3, then this is 3. Well, then this has to be 3 as well. But this side's actually going to be 2 and 2. Now, in order to find the lateral surface area is just the combined area of all the lateral faces. So you're going to combine the area of all lateral faces. Okay, which all the faces are in red here. So I have a 2 by 3 rectangle. So if you do base times height, the area would be 6. I have a 3 by 4. So 3 times 4 gives me 12. I have a 2 by 3, which again gives me 6, and a 4 by 3, which again gives me 12. So our lateral surface area is just going to be 6 plus 12 plus 6 plus 12, which equals 36. And I'm talking inches, and I'm talking area. So even just like our flat area, we're going to say inches squared. And that would be the lateral surface area because that's everything but the base. So everything but the base is just what you see around the sides. Now, if I want the total surface area, or just like the regular surface area, I'm going to take the lateral surface area but add in the bases. So each of these bases is 2 by 4, so the area of each of them is 8. Okay, so I'm going to take my 36 and add my 2 bases, which is 36 plus 16, which is 52 inches squared. Okay, so again, that's how much wrapping paper you would need to cover that rectangular prism. Here we have a triangular prism, so the first thing you want to do is figure out how can I visualize this flat. Once you visualize it flat, it's basically just finding area of a compound shape. So this one has 3 sides on the bases. That means there's 3 rectangles attached because there has to be 1 rectangle attached to each side. So I'm going to draw my 3 rectangles. Oh man, my drawing's not so good today, huh? So here are my 3 rectangles. Now this rectangle has a base of 4 and the height is 10. So one of them is going to be 4 by 10. And actually the height of this whole thing is 10. So all of these sides will have to be 10. However, this one's a little bit different because on this side, the rectangle is going to have a base of 3. So one of them will have 3. In the last one, the base is over here of this rectangle. So I have to find what that is because I'm not given it. So in this case, you're going to have to use, well, I know this is a right triangle. I have 2 sides. I'm missing the third. How do I find that? The answer would be Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared. And I'm really combining everything I've learned for like the past many, many months. So I have 4 squared, whoa, craziness, plus 3 squared equals opposite the 90 is my hypotenuse. So that's got to be the c. So 4 squared is 16, 3 squared is 9 equals c squared. 16 plus 9 is 25. In order to get c alone, you have a square. I got to undo that. A square root undoes a square. So those will cancel, and you're left with c is the square root of 25, which is just 5. So this side is 5. So I have one side that's 4 by 10, one side that's 3 by 10, one side that's 5 by 10. Okay, and then my 2 bases are going to be attached to that as well. So let's say that this is one of them, and then this side would be 3, this side would be 4, this side would be 5. Okay, and I can throw the other base over here as well. So that side is 3, this has to be 4, and the hypotenuse has to be 5. Okay, so to find the lateral surface area, I would have to add up the area of all the sides. So there are 3 rectangles. One rectangle is 4 by 10. So 4 times 10 would give me 40. So that's the area of one side. The next rectangle is 3 by 10, which will give me 30. The next rectangle is 5 by 10, which will give me 50. So the lateral surface area would be the sum of all those, which 40 plus 30 plus 50 is 120. And since I'm talking, actually I don't know units in this case, so I'll just say units squared. Now if I want to find the total surface area, so I'll just call that T, T for total. Total surface area, I have to include the bases. So total means I'm going to take the area of everything on the shape. So I know that the lateral surface area is 120 units squared. I have to add the area of the bases. In order to find the area of a triangle, it's base times height divided by 2. If it's helpful, you can always separate this triangle, kind of draw it on its own. So here's my right triangle. There's a 90-degree angle. The 3 is over here next to the right angle. The 4 is right next to the right angle. And the 5 is the hypotenuse because it's a cross. So in this case, the base is 3. The height is 4. Sometimes it's helpful to separate it to visualize that. 3 times 4 gives me 12. Divided by 2 gives me 6. Now that's the area of just this triangle here. But in our triangular prism here, I actually have 2 of those triangles. So the total surface area will have to be the area of all of the sides, which is 120, we calculated that before, plus the area of the bases, which the area of one base is 6, the area of the other is 6. So that's 120 plus 12, 120 plus 10 would be 130, plus 2 more would give me 132. You can do that in your head, units squared. So that's how you find total and lateral surface area. I know I went through the area of each shape quickly, but that's because by now I expect you to know the area of a rectangle or a triangle without even thinking much. Base times height divided by 2. Area of a hexagon, area of circles, you need to know those as well. Now if you don't, you're going to need to spend extra time going back to old material. So with that said, I'm leaving one problem for you to try. So on this pyramid problem here, I'd like you to test yourself. Can you find the lateral surface area and the total surface area? So go ahead and draw it as a net, do that on your own, and ask questions if you have them. Good luck.